I have to update my YouTube. I updated it. So we're gonna let that be. Let's see. I think that looks good. Let me check it one more time. I'll go here. Yeah, there is one person that left, but you know. Let me share my screen. I could just redo the attendance. And like this, and we'll start here. All right. So greetings, scholars. Let's see. As far as, so the main announcement. Okay, so we finally came to a conclusion with, the discounted access to my math lab. So I think the deal is you should be able to get 2 years of full access to my math lab for $100, and you can retrieve that by going to the bookstore. So if you go in the bookstore and just kind of explain it, say, hey, I'm under the impression that we get a discounted rate for 2 years of full access to my math lab, they should give you an access code that should give you full access. Okay. So that's the conclusion there. Okay. Okay. So this week we're still working on section 1.4. I think last time we said that we got through as much of the lecture together as we can, and which is a little shy of halfway. And again, anything that I would say in those lectures is already in my pre-recorded videos. So instead of working on the remainder of the lecture today, which you already have access to, we're going to work on as many homework questions together as we can. Okay. So let's just hop over. And as always, if you have questions or concerns about anything, feel free to either unmute yourself or type in the chat. I am monitoring the chat. Let me just hop over to Zoom really quick. Give me just a moment. Okay, let's see. Zoom. And I am going to join. Don't switch. Yes, that's correct. Turn that off. Don't connect to audio and join. Okay. Stay as a participant. Got it. That looks good. All right. Okay. So we're working on section 1.4 here. Start the test. No. What did I click on? I don't want the quiz. 1 for the homework. Okay. Do this really quick. I need a screenshot of this. Can I copy and delete? All right. Let's see if it'll work. Paste. Yes, that's looking good. Come on, you can do it. I believe in you. Oh, come on. I tried. Let's cancel and paste again. See if that works. No, that sucks. Yeah, my device has kind of been throwing a tantrum all day. Just kind of, you have to bear with me. Let me try copy and delete one more time. And here, I would like to paste. There we go. Now it works. Okay. So I will save that for reference, and let's get it going. Okay. So, I have my little mini game. What number do you think Google is going to choose? For some reason, I'm going to choose 23 this time. I know that's on the edge. Hey, Google, give me a random number between 1 and 23.
4.
4, way off. Couldn't be any further away. Free marketing for Disney. If you have Disney Plus, they just released what? The Little Mermaid and Elemental, or elemental, something like that. I like that. I like those ones. They're fun. Okay, let's look at this one. So, come on. Find the intervals over which the given function is increasing, decreasing, or constant. So for something like this, I would look at the graph. I'm just going to do a rough sketch. So one way to graph this, you can plot points. Choose several values of x, find the corresponding y, plot the points, and connect the points with a smooth curve. Normally, a cubic function is like an S shape where it's increasing, but because of that negative in front, it's going to be decreasing. So instead, when you trace it left to right, instead of going up, when you trace it left to right, it's going to go down. So I would just encourage you to look at that graph, and we can do it. We'll look at it in the graphing utility. We can get this to work. Okay, right here. All right. Reload and refresh. Oh, we lost. Here it is. Okay, so if you're working on now, I'm working on the TI-83 Plus. I know another site that students like to use is a site called Desmos.com. Matter of fact, let's do a quick demo on Desmos. So instead of the calculator, let me think. I'm going to go to Desmos because this is a free. It's a free online graphing calculator. So I'm just going to click on graphing calculator. I'm not 100% sure of like the coding. It's like a language or whatever. Let me see. So I'm going to type f equals negative, or here, let's do f of x equals negative 3x to the power of 3. Okay. So notice, and then we can change the window and the size and the tick marks and all of that. But notice as we trace it left to right, it's steadily going down. So again, this is just Desmos.com. It took me literally 30 seconds to go to the address, click on graphing calculator, and type in a function, right? So again, this is one that I know is popular with a lot of students. So as we look at this image, as we trace it from the left to the right, the image is falling or decreasing. So we say that the function is, there is no interval over which it's increasing. So it's never increasing. We're going to check. Okay. Decreasing over the domain of that image is all reals. So domain of this image is the very left to the very right. Now you have to understand the concept, right? That there are no asymptotes here. So even though it looks like it's not defined when x is -5, you have to understand that it's just way, way, way up off the screen. Like, let me see, if we were to zoom out, eventually it will cross the 5. So if you plug in a 5, that's like 375, we would have to get all the way up to 375, right? It's kind of hard to see, but it's there. Yeah, you can't see it because of the thing. But, oh, wait, there it is. So when x, right there, or we said -5, right? Notice here, when x is -5, you see the 375 right there. And what I did, I just basically clicked and dragged. I didn't even know we could do that. All right, so it has a lot of like capabilities. And I'm working on the iPad, so I just like pinched and zoomed to do all of this. All right, so but we just saw that when x was -5, even though it looks like it doesn't connect, it's actually just way, 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 way up the graph, right? So any x that you choose, you know, there's a corresponding y here, right? So the domain here is all reals. Let's check our result. It should be decreasing. And then it's not constant anywhere. There is no interval where the function is constant, okay? That was a fun little demo. I didn't even do that from an earlier class. Okay, let's do another one. I'm gonna go with 13. I don't know why. I just keep feeling 13. I'll probably start choosing different numbers this time. But... Hey, Google, give me a random number between 1 and 23.
19.
19, all right. Let's check. Let me check on Zoom really quick. Well, I still got a few seconds. Let me see. Yeah, let me at least open up 19. Yo. Okay. So for this function, construct and simplify the difference quotient. Oh yeah, difference quotient is fun, right? Okay, let me walk you through this. This one tends to give students a hard time, so let me get a copy of it. So far, my device is behaving. Thank you, device, for behaving. Let me copy and delete. I think I pressed delete. I don't know what I just hit. I may have clicked the wrong button. Okay, let's paste. Nice, thank you. And also, so I mentioned those movies on Disney Plus. If you have HBO Max, it's not really called HBO Max anymore. Where'd it go? Let me just paste again. If you have Max, I don't know if you're like a DC fan or not, but they have Flash. That's been on there for a couple of weeks now. Come on. There we go. Thank you. So it's just like recent movies that were recently in theaters or now streaming. Okay, so we want to do the difference quotient for this guy. Okay. So the difference quotient, it's the precursor to this concept in calculus called the derivative. And what the derivative is the slope of a tangent line at a point. In calculus, what we do is take this difference quotient, and basically what h is a small change in the x value. So as that small change gets smaller and smaller and smaller, in other words, as that h tends to 0, we get a better and better approximation for the slope of the tangent line at a point, right? That's the calculus extension of this concept. For our purposes, we're just doing the algebra, right? And in calculus, like for us, when we do the difference quotient, we have this kind of like long, drawn out, simplification that's going on. But in calculus, we have a shortcut where you can look at your question and just write the answer. There's a shortcut where you don't have to write all this out like we do. But for right now, so let's see. We're starting with f of x equals x squared minus 9, right? So now the difference quotient, I would recommend breaking it up into parts. So, hey, Google, give me a random color. Please. What are you doing? Please stop. Thank you. I think I just avoid red for whatever, because it's like a power color and it kind of creates anxiety a lot of times in students. So try not to use red. I'm going to use orange instead. All right, so first let's do f of x plus h, all right? So all we're doing is writing f of x like normal, but replacing x, matter of fact, let's change it up just a little bit. No, let's undo, let's get rid of style. Okay, so all we're gonna do is write f of x like normal, but replace each x with the orange thing. All right, and so first we're gonna replace each x with a blank set of parentheses, and then what item goes into the blank parentheses? The orange thing, right? So we only have one x, so one set of blank parentheses, and we plug in the orange thing, okay? So then we expand and simplify, So here we have to FOIL, all right? FOIL, first, outer, inner, and last, okay? And I'm pretty much just using these questions as a launch pad to kind of like expand on some concepts. Okay, so now if we FOILed, so by first, outer, inner, last, what I'm referring to, we're doing this x plus h. Squared means multiply itself by itself twice. So x plus h, right? Minus 9. So first, let me see. First, outer, inner, and last. Okay, that's what we're going to be doing. Okay. And what we did here, we just expanded. Okay. So if we FOIL, we get x squared plus xh plus xh plus h squared minus 9. Then let's combine like terms. Combine like terms. Just being a little bit OCD. That looks good. Okay. So if we combine like terms, we have this x squared. Like terms are going to be like this guy with this guy. Those are like terms. Okay. So that's going to give us plus 2xh plus h squared minus 9. Okay. So that's the expansion of f of x plus h. So now the next part, let's go ahead and do f of x plus h minus f of x. So we're going to say f of x plus h minus f of x. In other words, we're going to take that result that we got, this x squared plus 2xh plus h squared minus 9. We're going to subtract f of x. Notice I did a blank set of parentheses. My f of x is x squared minus 9. Those blank parentheses are important. They help us to realize that, hey, we need to distribute that negative. Common error, if we wrote this without the parentheses, we might be tempted. Nope, not that one. Cancel. It's fine. This one. Without the parentheses, we might be tempted to only apply the negative to the x squared and forget about this 9, right? So, but we need to distribute, which means the negative applies to both of those guys, okay? So then, if we expand, now we're going to have x squared plus 2xh plus h squared minus 9 minus x squared plus 9. Now, a hint when it comes to difference quotient, you know you're on the right track when you start having cancellations. Like notice this x squared cancels this x squared, this positive 9 cancels this negative 9. So that's a sign that we're on the right track. Okay. So again, x squared is canceled by x squared, 9 is canceled by 9. And that leaves us with 2xh plus h squared. Okay. Oh, wait a minute. We still got one more step. Delete, right? So, you know, f of x plus h, we got this part, and then f of x plus h minus f of x, we got this. Now we got one more step. We need to do f of x plus h minus f of x. We got to take that result and divide by h, okay? So we're going to take this 2xh plus h squared, and we're going to divide by h, okay? So now on top, notice we can factor out an h from each term. We're going to be left with 2x plus h divided by h. These guys cancel. And now we have our final result of 2x plus h. Okay. So again, my recommendation when doing difference quotient is to break it up into parts. If you try to do it all at once, it's easy to kind of get like overwhelmed. And I'll also say that it is difficult to follow somebody else's work. All right. Like I've always that way. Whenever it's like if my professor, when I was a student, you know, when I was in a classroom or whatever, trying to follow theirs, it always gave me a headache. Or trying to follow my classmates or anybody else. The only way I can see it, I would just kind of like watch to get an idea. And then I wouldn't see it until I tried it myself, right? So, you know, I don't expect you to keep up with all of this, but because it's a recording, that's kind of why I power through. You could always go back and change the rhythm or whatever. But you really don't see it until you start doing it yourself, right? With these kind of presentations, just kind of absorb what you can to just get a gist of it and then go and try it yourself. It's not until you try it yourself that you get it. This is an active learning experience, not passive. Like if you're passive, it's a lot harder for this stuff to sink in. It's not until you get some reps in that it starts to sink in. Okay, let's see if this 2x plus h works. So I'm gonna hop back over. I think that looks good. Hopefully it's also there. The difference quotient is we got 2x plus h. 2x plus h. Okay. I feel like there should be questions, but I'm not going to press the matter. Let me check on you guys in Zoom, see if we got any. I know I saw some people kind of come and go. Okay, let me get these gentlemen. It's going to be. Let's see who's here. I know I saw that student. Yeah, we can do 20. We'll do 20 next. And I think he was here and he came back. That's cool. I think, yeah, I got him already. Let these gentlemen in. Let me see. Let me check my numbers. So if I go here, cool. Yeah, we're still kind of missing one, but that's okay. If it was x squared plus 9, would it be 2x squared plus 9? Let me see. What were we working with? We had x squared minus 9. More than likely, the 9s would cancel. I think it would be the same thing. I mean, without working it, I think it would still be the same answer. But yeah, you would kind of need to do all of these steps. Okay, so there was a request for 20. Let's hop over to 20. Okay, yeah, we're good. Let me just clear this out. Okay, let's look. Let's go here. And so basically, how you see me doing this, like when you're working through the homework, if you would like my input, I reply as soon as I can. Let me hop over to 20, for instance, and I'll show you what I mean. So if we open up question 20, all right, say you're working this and you get stuck, right? So you click on the get more help. The view an example will basically walk you through it with an explanation. You also have the e-textbook there. And then if those aren't working and you've kind of like done everything you can think to do, that's the best time to do the Ask My Instructor. You can try doing the Ask My Instructor first, but sometimes I get busy and I can be kind of slow about responding. Additionally, if you haven't like been frustrated with the question for a little while, when I give the explanation, it typically doesn't sink in. But if you've been frustrated for some amount of time, not too long, but just enough for it to kind of like, you've kind of exhausted everything you could think to do. As long as you're frustrated for a little bit, then when I give the same explanation, it usually sinks in, right? Okay, so for this one, notice that there's no x, right? So when we do the f of x plus h, there's no x to substitute, so it's just going to be -9 minus -9 divided by h. 0 is basically going to be 0 divided by h, so that one should just be 0 because there's no x in the original. There's no x to substitute. Did that make sense? Hopefully that made sense. That one went way faster than I anticipated. I was getting ready to like get a screenshot. Yep, my pleasure. I was getting ready to like get a screenshot and write it, but I was like, no, this one is fast. Okay. Hey, Google, give me a random number between 1 and 23. Man, everything is dragging it.
Here's a random number, 23.
That's what I said earlier. Okay. Okay. Let's see. Let me start by, let me think about this. Let me get a copy of this. Right, and the question has the question ID, right? That tells us where in the textbook it's coming from. If we hop to section 1.4, question 76, it should be the exact same question with different numbers. Let's hit copy and delete. Let's create some space for ourselves. Come on. Space. Come on. All right. So again, this comes from section 1.4, question 76. It says Kara's custom tees experience fixed costs of $400 and variable costs of $2 a shirt. Write an equation that can be used to determine the total expenses encountered by Kara's custom tees. Let X be the number of shirts. Let C of X be the total cost of producing X shirts. Then calculate the cost of producing 5 shirts. Let's read it again. Kara's custom tees experience a fixed cost of $400 and a variable cost of $2 a shirt. So this one actually isn't too bad. I'm just going to hop here. So the fixed cost is just going to be, so when she goes to produce her shirts, to get started, she needs at least $400. That's like the startup fee. And then for each, from that point to produce, each shirt she produces costs her $2. So it's 2 times each shirt. We're going to let each shirt be X. And I think that's it. So for instance, if she produces 0 shirts just to get started, it costs her $400. If she produces 1 shirt, right, it's going to be the $400 plus the $2 for the shirt. 2 shirts, 400 plus 4, so on and so on, right? And so you can see how that fits this. I'm going to hit enter. Okay. So then we want to get the cost of producing 5 shirts. So then once we have our function, we let X be 5. 5 times 2 is 10, plus 400 is $410, right? So then what she could do is play around with different costs. I mean, different prices. Like say she sold her shirts for like $5. How many shirts would she need to sell in order to break even? How many shirts would she need to sell before she turns a profit, right? And then she can do different prices. Well, what if she sold the shirts for $3? What if she sold the shirts? Can she sell the shirts for $1 and get back in the green? Right? Probably not. If it costs her $2, right? So she at least needs to sell them. But $2, she'll never. She won't grow. So something over 2. But we can do some calculations there if we needed to. Okay. All right. That wasn't too terribly bad. I was getting ready to write it all out. Hey, Google, give me a random number between 1 and 23.
8.
Okay, let's look at question 8. Determine if the function is even, odd, or neither. Yes, this is a good one. So let me get a copy. And we got our question ID. Oh, homecoming is going to be coming up soon. What, towards the end of August? Done. Let's copy and delete. Here. I'm going to just delete this because we didn't do anything there. Delete. Paste. Thank you. All right. So for even, odd, or neither, let me do the following. So first, let's recap. What's the definition of a function being even, odd, or neither, right? So the definition of a function being even, whenever we evaluate f of negative x, we get back to the original. The definition of a function being odd, whenever we evaluate f of negative x, we get a negative times the original. Okay, those are the official definitions of a function being even versus a function being odd. Okay. When a function is even, that's the same as y-axis symmetry. Okay, so you can fold it along the y-axis and it's going to match. When a function is odd, that's the same as origin symmetry. So that's where, like, if you cut it in half along the x-axis, put your thumb on the origin, rotate the top half 180 degrees, is going to match the bottom half, right? With an odd function, whenever we have x comma y, we also have negative x comma negative y. So you can use that symmetry to generate several points. They're going to be symmetrical and equidistant about the origin. So when you get one point, you automatically get another. And then for y-axis symmetry, whenever we have x comma y, we also have negative x comma y. So whenever you get a point on one side of the y-axis, you automatically get a point on the other. If you think like a parabola, a U-shaped curve. Whenever you get a point on the right, you get a point on the left. Okay. Okay, so I'm going to shrink this down as a reference. Man, this is like my first of 3 classes, and I'm already like, I don't want to talk anymore. I mean, I enjoy these topics; they're interesting to me, but it would be nice if I can just like do the presentation like once for maybe an hour or two, and then everybody watches it instead of staggering it like this. And then like if you can't make the time, then just watch the recording. But I mean, I get the thing about being live, but then students typically don't ask me a lot of questions. So I don't know. Like, to me, it would just be easier. Just let me do it once. I could go longer and then call it a day. Right? If it were my school, that's what I would. One of these days that'll happen. Okay. All right. So let's do this test. All right. So we're going to replace each x with negative x. So first, we're going to replace each x with a blank set of parentheses. Okay, each x with a blank set of parentheses, and then into the blank parentheses goes negative x, and negative x. Okay. Okay, if we multiply an odd number of negatives, the final result is going to be negative. So that's going to be a negative x to the 9. Same thing with the second one. And then we ask ourselves, is this the original? No. So then let's factor out a -1 from all terms, and that'll give us x to the 9 plus x to the 7. Is this negative times the original? Yes. All right, this is a negative times the original. So we started with f of negative x, and we finished with negative times f of x. So then does that mean the function is even, odd, or neither? All right, that is the definition of a function being odd. Right, so we would have origins in it. Okay. So if we were to guess, we would have a chance favors the prepared mind. Let's click on odd. So I guess when you like do your homework, when you prepare, you boost the odds of success in your favor. I guess when you practice, you boost the odds of success in your favor. Because practice makes what? Hopefully you're not saying perfect. Practice makes improvement. If practice made perfect, we would never have to do it again. And we all know what happens as humans when we stop doing something. What happens to our skill level? It goes down. All right. So it doesn't make perfect. It makes improvement. Either you're getting better or you're getting worse each day. Okay. Let's see. Hey, Google, give me a random number between 1 and 23.
Here's a random number, 21.
21. Let's see what's going on with 21. I like the random thing. That helps me. Let's see. It says the graph to the right shows a particle moving on a coordinate line with a velocity v equals f of t at time t seconds. Find the domain and then interpret it, right? So it looks like it's t seconds. The domain is the very left to the very right. So how far left does this graph go? How far right does it go? The far left looks like it's x equals 0 or t equals 0. And the far right looks like it's t equals 20 seconds. Type your answer in interval notation, so 0 to 20. It looks like we're including the 0 and the 20. It reaches those numbers. So we're going to do square brackets, 0 to 20, square bracket. Can anybody explain the difference between a square bracket versus parentheses in this context? Any brave souls? So square bracket means, like in this context, we get really close to 0, and we do include 0. So we include the endpoints. Parentheses means we get really close to those numbers, but we do not include the number itself, right, in this context. Okay, was that it? Oh, and then interpret, what does this mean? So a particle moving on a coordinate line with this velocity. So this domain, what is it telling us? That it traveled for 20 seconds. The particle takes on all velocities between, the particle's motion is tracked from time equals 0 to, the particle's motion is tracked from time equals 0 to time equals 20. Yeah. All right, let's go with that one. Hey, Google, give me a random number between 1 and 23.
Here's a random number, 17.
All right, 17. She's doing a pretty good job of getting different numbers. Let g of x be this equation. Find the average rate of change of the function as x changes from -1 to 4. Okay, so for our purposes, when we see average rate of change just means find the slope. All right, so then if they gave us two different x values, that means we could find the corresponding y values, find the slope between those points. That's all. So average rate of change just means find the slope. Okay, so let's get a copy. Oh no, we only got 5 minutes. This will be the last one. Matter of fact, just in the interest of time, I think I'm just going to go ahead. Let me delete this. I'm just going to work it here. So slope is the rise over run, which is the change in y over change in x. X, y. So, sorry. So when x is 4, let me see. If we plug in 4, that's a 16 times 6, which is 60 plus 36, which is 96. 90 minus 3 is 87. Okay, so our y2 looks like it's an 87. Let me, I need a fraction. You're doing that thing. Okay. I'm not writing it all the way out because I'm kind of short on time. If I can get this to work. Why aren't you working? What? Why? I don't understand why you're not working. Okay, close this out again. All right, let's do a fraction. There we go. So our y2 is 87. Our y1, if we plug in -1, 6 minus 9 is a -3. So I'm going to do parentheses -3. I'm essentially just taking my notes here. My x2 is 4 minus -1. Okay. So basically what I did here was y2 minus y1 equals, y2 minus y1 over x2 minus x1. Okay. So double negative is positive. That becomes 90 divided by 5. Okay. That's a 1 with a 4. That's 8. 18, right? That makes sense. So the average rate of change we get is 18. Okay. I just did it that way because we were short on time. Okay. Are there any burning questions? Any burning questions for me? Let me do this. Oh, you are like dragging. Share, send it to box. Let me make sure it's in the right folder. 23, traditional, updated daily. Okay, you can go there, send the box. Okay, so when this bar finishes loading, you'll receive a copy of anything that you saw me writing. It might be a good idea for today to maybe watch, because I'm basically doing the same structure with like my 9 a.m., my 2 p.m., 3 p.m., 4 p.m. classes today. You all are studying College Algebra 1, but we all go through different question sets. So if you want to see more, just watch the one like from 9 a.m. I'm about to do my 3 p.m. in like 15 minutes, right? And then I got a 4 p.m., right? So you can see some other questions other than the ones we did together. Okay? So if there aren't any burning questions, we're going to end the session here. And from one beautiful mind to another, have a great weekend, guys. I'll see you next week, same time, same place. Take care. Peace. I think the chat is good. Square includes. Yeah, the square includes. Thank you. Yeah. Oh, I think there was a request